just calculator, really, which I should probably get out of my bag. Okay, so first two, calculator practice. All right, 5 permutation 2, 5 math, probability, permutation 2 is 20. 15 math, probability, combination 11, 1,365. Okay, there's those two. All right, now number 3. So what we're going to do for number 3 is we're going to read the problem, and then we're going to set up one of these, and then we're going to go to the calculator. A group of 30 people need to take an elevator to the top floor. They will go in groups. This is the keyword here. Groups of 6. Is groups permutation or combination? Combination. Okay, so we have a big C for combination because it says groups. And then we say, okay, what's the total? 30. And how many are in each group? 6. So 30 combination 6. 30 math, probability, combination 6. Oh my, 593,775 different groups. Glad we don't have to make a tree diagram for that. Okay. All right, so the student body of 100 students wants to elect a president, vice president, and secretary. Is this arrangements or groups? This is an arrangement. It's an arrangement because the president title is very, very different from the secretary title. If you come tell somebody that wants to be president that they're going to be secretary, that's a very different conversation from, do you want to be in our group? So this is an arrangement, which makes it a permutation. Okay, we have 100 total students, and how many are going to be chosen? 3. Jacob is the master of combinations and permutations. Or it's just that you sit right next to me. 100 math, probability, permutation. Wow. So the moral of the story is if you get giant numbers for these answers, don't freak out. All right, we are done with the packet completely. Packet can go home in the binder or notebook front, or stuffed lovingly into your backpack in the skew fashion. Lovingly. I love these warm-ups, they're so quick. Ah. I know, but if you look further down the packet, I know. And it's going to happen again if you look ahead, because the next two are Pythagorean identity. Okay. So today we are going to do pretty much exactly the same thing we did on the block day, just not as many of them because it's not a block day. I know you need more practice at this. So that's a good thing. We're going to do 2 problems. There's also notes, but the notes is inside one of the problems, so it's not its own thing. We have 2 objectives today. We will generalize a method for calculating the sum of an arithmetic series and then apply it. We already kind of did that. It was Gauss's formula. Sum equals n over 2 first term plus last term. You guys remember that? Okay, so The first column, number 21, is going to be another one of those rectangle ones. And then we're going to get into the notes in number 24. And then the end of 24 is those ones where it's like you have to figure out the equations and, you know, like it's a puzzle. Like you have all these numbers and you have to figure out where to put them and what to solve for. So that's the other piece. Students will use the equation of an arithmetic sequence and the formula for the sum of an arithmetic sequence to find the series and calculate the sum. Do you remember number 6, kind of how spicy that got on the block day? That's what I'm talking about there. Here's your joke and homework. So your homework is 30 to 36, and the joke says, 7-year-old me seeing an X in math, 17-year-old me seeing a number in math. Yeah, it's true. It's true. Except for we've got a lot of numbers in this chapter 10 deal so far. All right, here's the top. Go ahead and set that up.
I have no idea. I don't want to talk about that. That's not going to happen. That's not going to happen.
Are you guys ready already?
Yeah.
It's loud, like people are ready.
It's not.
Hello. You guys ready now?
Yeah.
All right. Sounds good to me. Why not coming? Ha. Technological difficulties. Okay. Number 21. While trying to calculate the sum of an arithmetic series, Antonio draws a graph of the terms. He notices that he can take the rectangles representing the second half of the term, rotate them, and they will fit perfectly with the rectangles of the first half of the terms. Oh man, Antonio, it's full of Gauss stuff right there. Use this graph to answer the question below. How can, this is the dumbest question, but how can Antonio be sure that the rectangle, that the result of stacking the terms this way will be a rectangle? Okay, but what if it's a different one?
Add them all.
Yeah, exactly. They add up to the same number, right? That's good. So the area of the original graph will be this area of the rectangle, which is kind of what is, you know, that's like important for what we were doing. So the area of the bar graph equals the area of the rectangle. Okay, B. What is the sum of Antonio's series? How do you know? Okay, so we're going to use the formula that we worked with yesterday. Let's write that down again. Sum equals n over 2 first term plus last term. This is me trying to burrow this formula into your brain. So it'll be in there. Okay. All right, now take a look at the original graph before he rotated it. How many terms is in this series? 16. Okay, so you guys write on your paper, sum equals 16 over 2. Okay. And what is the first term? I'm pointing over here. 2. And what is the last term? It's 10. I think it's 10, or is it 11? 2. It's 11. It's 11. Sorry, I just cheated and looked ahead. It's 11. Okay. 2 plus 11. Okay, now we're going to do this with no calculator, assuming a quiz. So the first thing I would do would be 16 divided by 2 is 8. And then 2 plus 11 is 13. Okay, then I come over here. 13 times 8. Yeah, and you can just do 8 times 3 plus 8 times 10, which is how I do it. But anyway, so this is 8 times 3 is 24. So you take the 4, put the 2 up here. 8 times 1 is 8 plus 2 is 10, 104. What? Yeah, but apparently people are telling me that they don't know how to add, subtract, or multiply or anything. So. Trying to, fill in some of those gaps, chasms, volcanoes, Grand Canyons. Yeah. Okay, C. Which terms of the series form the first? Okay, this is actually my favorite part of this whole problem. Which terms of the series form the first column? So if Antonio took all of these over here and flipped them upside down and put them here, which 2 terms would form the first column right here? Term 1 is right here. And what's this one?
Last term.
What is the last term? First term plus last term. Oh, am I trying to make sense out of Gauss right now? Okay, so first term plus last term, which would in this problem would be the first term plus the 16th term, which happened to be 2 plus 11. Do you see what I'm doing here? So this is this and that added together to make that column. And then what's this? What is the height of this column, of this new one after these two are put there? 13. Okay. D, last one. Write out Antonio's series and compute the sum. Okay, so in this problem, they just want us to verify that we're not making up like crazy rules for math that aren't real. So Antonio's series starts with 2 plus, they go up by 1 each time? I don't remember. No, it goes up by, we don't know. We're gonna have to figure it out. Okay. What? Yeah, there's 16 of them. Okay. So let's do this. We're gonna put, okay. So this is how we're gonna be smart and lazy. So we're gonna say, okay, as I told you guys, College Board, when you're listing number patterns for them, you have to write the first couple plus a dot, 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 and plus the last one. Okay, we are not doing College Board work here, but I feel like if that's okay with them, that should be okay with us, that we don't have to list out the whole thing, right? That's what I'm saying. Okay, so what we need to do is figure out what D is. Okay, anybody know a way that I can figure out what D is? Does anybody know something I could do, say, perchance? Like if I'm stuck, I don't know. I thought maybe I told you, oh, I could find the equation. Okay, I'm gonna do it over here, by the way, where there's more space. Okay, now, next question. Can I find the equation with the 0th term? Can I figure out what the 0th term is? No, I don't know what D is, so I can't find it out. Can you two focus, please? Okay, so I'm gonna have to write it in terms of the first term, which is this. This is the first thing we learned on the block day, which is how to take what you're used to doing, the equation in the 0th term, and write it in terms of the first term. Okay, let's see if we can use this to figure out D. What is T of n? What does T of n even mean? You guys are, I'm hearing all the wrong things. What is this? T of n. Last term. What's the last term? I wrote it for you in a blank and everything. D is what we're solving for. How many terms are there? 16. See right here, and 16. And then what's the first term? 2. Oh, yeah. Thank goodness you're here. Okay. 11 equals 15D plus 2. 9 equals 15D. 0.6 equals D. Well, that's why we couldn't figure it out, because it was a decimal. So 2.6, 3.2, blah, 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 to 11. And what is the sum of that series? 104. Good. Good stuff. Good stuff. Okay. If I move this here, are you guys all caught up to here at least? Okay. So go ahead and set up whatever you can. Okay. Arithmetic sequences. We are going to make 2 bullet points here. And we are going to define what arithmetic sequences are. First thing you need to know is that a sequence is a pattern, a number pattern with commas. Commas make something a sequence. Okay. What makes them arithmetic is that they're repeated addition of a common difference, d. Very important that you guys know that d can be positive or negative. You guys know that adding a negative is the same thing as subtracting, right? When did you learn that? When you learned that with Cecil and the tightrope, I'm pretty sure. Cecil? Yeah. 10th grade, Cecil? You know, we walked out on the tightrope 5 and walked back -6 or whatever, and then it was integers. How you learned integers? Oh, okay.
For me.
Okay. Well, that's over. So now, okay, we have, just make sure that you understand that when I say addition, I don't mean that it has to be a positive every time. D can be a negative. We had that, yes, no, it wasn't yesterday. It was Wednesday. If you guys remember, it was going down 14 each time. So D was -14. Okay, anyway. Okay, arithmetic sequence equation. There's 2 of them. One of them uses the 0th term, which is T of n equals dn plus T0. This is the one that we're comfortable with. We're familiar with that one. It's y equals mx plus b. Okay, and we learned a new one on the block day that's in terms of the first term. And sometimes we have to use that. We learned. So T of n equals d n minus 1 plus t1. We learned that if we distributed d and combined like terms, that these two would end up being the same thing. So it's okay to use either one. Do you have recollection of that? Okay, and then we learned a formula, Gauss's formula for the sum of an arithmetic series. Sum equals n over 2 t1 plus tn. So this is all just review from the block day. I just wanted to put it all in one spot in your notebook so you could like flip back to this. It would be easy to find. Okay, I have an example for you. It's 11 plus 18 plus 25, blah, blah, blah. And the first problem for this, first thing for this says find the equation. Okay, so we're going to do both because we are new at this. You don't have to do both on your quizzes or tests or anything. You can just do one or the other. I'll have both answers on my answer key, so that's not for you to worry about. Okay, in this problem, what is D? 7, right? So D is positive 7 in this problem. I don't know what's happening. Okay, and then what would the 0th term be? 4. Okay, so when I write my equation in terms of term 0, I'm going to say T of n equals 7n plus 4. Okay, when I write my equation in terms of the first term, I'm going to say T of n equals 7. Same thing, starts the same, still the 7. I back up the train on the n, and I balance that out by putting the first term here instead of the 0th term. Okay. Find the sum. Okay, so we're gonna write sum equals, and we're gonna plug in as many things as we can to see if we can fill in the whole formula. But I think I'm gonna get stuck right away. Can you guys, do you know how many terms this is? I don't know. If I don't know, you probably don't know. So we got something over 2. What's the first term? 11. And what's the last term? 74. Okay, so we have a hole in our sum formula. I think I said this about 47 times on the block day, and I'm going to try to say it 392 times today. Whenever you get stuck on that, go to the equation. You have both. I think this one's easier to plug into, so I'm going to go here. T of n equals 7n plus 4. Okay, what thing is supposed to go right here in Gauss's formula? N. Okay, so that means I need to solve for n, and I need to plug something in over here. What spot am I interested in finding out what it is? 74. Great job. 74 equals 7n. Oh, wow. Now I think I feel stupid. Did you? Also, I'm gonna write, just for my visual people up here, I'm gonna write 1, 2, 3, and then I'm gonna put a little question mark there so you guys can see what we were trying to do. We were trying to figure out what spot 74 was in. What? That's a question mark. It's a tiny, tiny question mark. Here, hold on. Let me make it. Okay. All right, now let's see if we can do this with a calculator. I'm gonna let you use a calculator on B and C, but just because, you know, we have each other here, sum equals 5. What's 11 plus 74? 85? Okay, so going back to our two objectives for today, did we figure out a method for finding the sum of a series?
Yeah,
Back to yesterday's objectives, do you understand the difference between a sequence and a series? Sequence has commas, just a pattern. Series has pluses and it has an answer. So it has like a sum that you add up. Okay, just checking. Okay, I'm gonna put the problems B and C up, and I want you to do those two in your groups. I'll put the answers up in a few minutes. Because you guys need to practice. Not in a bad way, it's just really, really new. Okay, it's right here, B and C. B is so easy, you're gonna feel like you're doing something wrong. Just checking, it's not you, it's the problem. N is the last one. I'm done. How are we doing? Did you get B? If you didn't get B, you're overthinking it. B is like there's nothing to do, you just plug them straight in, go to the calculator. C though. Okay, so let me ask you this. If you have a formula, if you have an equation, how could you get the first term? What? Yeah, for C. How could you get the first term? Let's just say you wanted to know T of 1. Just plug in a 1. Yeah. That's, yeah, they gave you the equation already. That produces any number you want. The equation is magical. Yeah, so T1 is 4. Great job. Okay, then what number would you plug in to get the last term? Yes, haha. It's just a little magic formula that gives you every term you want.
I just. It's so funny. You know, yeah.
All right, so here's my business. My first one, I got 1,113. How we do?
Yeah, yes.
Okay, that one was probably so easy, it was hard because you thought you had to do more, but you didn't, you just plugged in a thing. And then this one, you had to realize the magic that they gave you the equation, which means you can get any number you want. So I plugged in 1 to get term 1, and I plugged in 25 to get term 25. And then I put here term 1 and term 25. And then you got it out. The equation is magical. It gives you any number that you want on the whole series. You remember when we used to call these function machines, that was the whole purpose of that. Like, that gives you any number you want out of there. But we don't really call them sequence machines. Maybe we should.